In this video, we are going to review the standards we talked about during Unit 2. So plotting fractions on a number line, converting between improper fractions and mixed numbers, and then solving real-world math problems involving fractions and mixed numbers. So first, we're going to talk about plotting fractions on a number line. There's some things to consider when we do this. So we have to look between 0 and 1, and then also between 1 and 2. Each of those sections is a whole number, okay? And in order to plot fractions, we have to split that whole number into equal sections in order to find out where our fractions would go. So in this problem, we have fourths. So if we look at our denominator, we can say, okay, our denominator is fourths all the way through. So between 0 and 1, and between 1 and 2, I need to break each of those whole numbers into 4. So I'm going to split it right down the middle to create two equal-ish sections. And then between 0 and 1/2, I'm going to split that in half, and 1/2 and 1, I'm going to split that in half. And I'm going to do that exact same process for between 1 and 2. So now I have 1, 2, 3, 4 sections between 0 and 1, and 1, 2, 3, 4 sections between 1 and 2. So now each of these tick marks is a fourth. So if I start for 7/4, I'm going to start at 0 because there's no whole number here, and I'm going to make 7 jumps to the right. 1, 2, 3, 4, 5, 6, 7. I'm going to put my point, make it kind of big, and I'm going to write 7/4. Then I am going to do 1/4. And again, there's no whole number here, so I'm starting at 0, and I'm going to do one jump to 1/4. And I'm going to plot my point. Now, this is where things get a little bit different because we have a 1 here. So instead of starting at 0, we're going to start at 1. And it's 1 and 1/4. So I'm going to take 1, and then I'm going to jump 1 more, and I am going to write 1 and 1/4. Okay, last but not least is 3/4. Again, no whole number here, so I'm starting at 0, and I'm going to make 1, 2, 3 jumps, and write 3/4. Something of importance to note is that even though we have 4 sections, we really only drew 3 lines. Okay, so just remember that you don't necessarily draw 4 lines because then that creates 5 sections. So make sure you're counting the number of sections you have when you are plotting these points. Okay, so now second, we are going to work out converting improper fractions and mixed numbers. I want to show you visually why what we're doing works. So if I draw fifths, right, I'm going to draw as best as I can. And it's not that great. They're not that even, but we'll make it work. So fifths, I need 13 fifths. So I have 1, 2, 3, 4, 5. So I'm going to need more. So what I'm going to do now is I'm going to do another fifth. And I'm going to keep coloring in. So that's 5, 6, 7, 8, 9, 10. And again, I still need more, so I'm going to draw another fifth. And my fifths are getting more uneven. So I have 10, 11, 12, 13. Okay, great. So what I'm going to do now is say, okay, well, I colored in 1 hole, 2 holes. So 13 fifths is really equal to 2. And then you have 1, 2, 3 left over. And your denominator is always going to stay the same. Okay, so our mixed number is 2 and 3/5. Some other ways to do that are to say, okay, well, what if I don't want to draw a picture because it's not super convenient? One way to do it is say, how many times does 5 go into 13? Okay, 5 goes into 13 if you're skip counting twice. 2 times 5 is 10. When we subtract, 13 minus 10 is 3. This comes up. And your denominator always stays the same. And you get 2 3/5. I have a lot of people that say, well, Miss Blunt, I don't really like division. It's still confusing. So you can take 13, your numerator, and you can take away 5. You get 8. Take away 5 again. We're seeing how many times can we take away 5 from this number? Well, that's it. If you can't do this one, so you take it away. And you say, we took away 1, 2 5s. There was 3 left over. And your denominator is always going to stay the same. So either way, any way you do it, you get 2 3/5. Okay, we're going to do that same process now, except for sevenths. Okay, so I'm going to draw sevenths over here. So I have 1 whole, 2 wholes, and then 3 wholes. And I'm going to shade all of these. This is 1, 2. These are not very even. That's okay. And I'm going to break it up into 7 pieces. 1, 2, 3, 4, 5, 6. That creates my 7 pieces. And I'm going to shade in 1, 2. All right. Well, that doesn't really help us figure out how many sevenths I have. And what we can do is we can say, okay, we're going to equal this, and we know our denominator is going to be 7. So in order to figure this out, I have to break these into 7 pieces too. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. And I can count all of my pieces. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. Oops, I picked the same color. 15, 16. So you end up getting 16 sevenths. Okay. Well, again, pictures are great, but they don't always work that way. And unfortunately, sometimes they just are too hard to do. So what you can do is you can say, okay, I'm going to take 2, and I'm going to multiply that by my denominator. 2 times 7 is 14, which is ultimately what we did right here, right? When we took these 2 wholes and we broke them into 7 pieces and then counted. 7 plus 7, or 7 times 2 is 14. And then we take our numerator, this 2, and we add it in. So that's what we did here. We added these 2. You get 16, and your denominator stays the same. Okay. Another way to think about that is, okay, I have 1 whole plus 1 whole, which is 2, plus 2 sevenths. Oops. Is going to equal something over 7, right? We don't know what that something is. Well, I know that this fraction is 2, okay? And this whole right here is going to be a giant 1. It's going to be 7 sevenths. This also has to be a giant 1. So that's going to be 7 sevenths. So 7 plus 7 is 14, plus 2 is 16, which is ultimately what we did when we multiplied the whole number by the denominator. It's just a couple different ways to see it. Okay, next we are going to look at adding these 2 numbers together. The nice thing about this is in our unit 3, we had to find the LCM to find equivalent fractions, so they had common denominators. We don't have to do that here. Here we can just start adding right away. So 9/5 plus 1 and 4/5. 9/5 plus 4/5 is 13/5. And then 1. Well, this is an improper fraction, so we need to convert that to a mixed number. So we're going to say, how many times does 5 go into 13? You get 2. And then you get 10. 2 times 5 is 10. Minus you get 3. This becomes your new numerator. Denominator stays the same. So instead of 13/5 now, you have 2 3/5. But in order To complete the problem, you need to combine your 1 and your 2 to get 3, and your fraction stays the same, 3/5. So your answer is 3 3/5. All right, so now we're going to move on to a subtraction problem. Again, our denominators are already the same, so we can just work out the problem. So 4 3/8 minus 1 7/8. Now 3/8 minus 7/8, I can't do that because 3 is less than 7. So what I have to do is I have to borrow. This 4 becomes a 3. So we agreed that 3 plus 1 is equal to 4. Well, because we're working with fractions, this has to be a fraction. So it's just going to be a giant 1 to give us 4. So we're going to add a giant 1 right here. So our value does not change. And to make it easy on ourselves, we're just going to bring this denominator straight over. So if my denominator is 8, my numerator needs to be 8 as well. So I'm going to add 3 plus 8 to give you 11. This becomes 11. 11 minus 7 is 4/8. So you get 4/8 here. 3 minus 1 is 2. And that is your answer. All right, finally, we are going to go over this word problem. I don't know why that stayed on there. This word problem together. Christina's making tortillas. Okay, so I'm going to draw a big bowl that I'm putting my ingredients into. She needs 2 1/3 cup of flour. So, okay, I need this much flour. She pours 1 2/3 cup into the bowl already. So how much does she need? How much more does she need? So in order to do that, we're going to subtract. We're going to take our total amount that we need, which is 2 1/3. We're going to take out what I already put in there, and that's going to tell us how much is left over that I need in order to make my tortillas. So I need to borrow because I cannot do 1/3 minus 2/3. So I have to borrow. This becomes a 1. We're going to take the 1 that we took away and we're going to put it over here. In order to make this easy on ourselves, we're just going to bring this over. This giant 1 is going to be 3/3. I'm going to combine these two. 1/3 plus, or 1 plus 3 is 4. So this is going to become 4. 4 minus 2 is 2. Denominator stays the same. So you get 2/3. 1 minus 1 is 0. So your answer is she needs 2/3 cups of flour in order to make her tortillas. And I forgot the S. Okay. If you need more help, visit office hours, rewatch the video, or let me know, and we will figure out a time to work on it together.